Okay, this is a demo of our distributors and who's using our CR10 for palletizing. And I'm going to introduce you about the palletizing here. So in the part of stack transporting or palletizing, there will be 4 tests. First one is getting familiar with Dobot Plus plugin. Second is programming of simple stack transporting. Third one would be programming of complex stack transporting. The fourth one would be the applications of stack process. Okay, so we just saw what is palletizing, and now we're going to do for the preparation. To use the palletizing, we will use the indicators, indefectors, or we call it. So for the CR robots, the standard we use is this ISO 9409/50/4/M6 standard. This is a universal standard that is suitable for most of collaborative robots. So this is how the standard is. You can see we have the diagrams in different angles. We can see that this is the flange that's suitable for the CR robots. We can use this to find the most compatible indefectors. And how do we communicate between the indefectors and the robot? So we have this. We have prepared the I/O and RS485 communication ports on the end of the robotic arm. You can see there should be a buckle on the end of the robotic arm. I'm going to show you later, and it supports I/O and RS485 communication. Those are the definition of the cables you can see from the table on the right. Okay, so those are the different definitions there. There are 8 different cables in this one. This is a zoom picture for this. So you can see the different definition. We have this 485A, 485B, DI2, DI1, and we have this 24 watts to provide voltage power, and we have DO2, DO1, and the right ones for the grounded. So you can choose. You can see from these definitions of this cable to choose the right endhorse. One thing we'd like to mention that the output on the end terminal CR products is NPN. This tab is NPN, and the input will be PNP, and the rest input and output on the controller cabinet is PNP. So this is a very tricky one, and you need to pay attention to that. So if you are using the PNP, you want to use the PNP type of indefectors on the end of arm, you will need to use a relay to transferring from NPN to PNP. Okay, so in the picture are some models that support our CR robots in the Dobot Plus. So we are developing the interface, the UI user interface for those different models, and lots of RobotTQ robots and the DH robots and Quenway 6-force touch sensors. The packages are all already available in our software. But now we are developing more for more brands and more models in the future. Okay, but if your NTOR is not included, you can try to communicate with the I/O or the RS485 model bus ITU. Okay. And here is the Dobot Plus. We choose from here, so you can see we have different plugins available. So we have this Athlon-like DH, the force touch sensor, which is from Quenway, the different models like FT300, OnRobot, RobotTQ, 2F85, EPIC, RQ, Also, this is the safe skin add-on. So I'd like to mention that if you bought the CR robot with safe skin, you also have to add it, install this plugin in the Dobot Plus. Okay, this is the Terminal 9.0 and the Wild package. This package is ready to release, and you can use our robot for some wild applications as well. Okay, once the package installed, and what we need to do first is set the ID and baud rate of the suction cup or the other infectors, and then we choose the baud rate, we choose the ID correctly, and then we initialize it. We are taking the RobotTQ peak, for example, in the screenshot, and this is what we do, and this is the interface of it. Okay. After initializing, we can see this user interface here. We can change the different levels, maximum level, minimum level, to give limits to the robot, and also we can choose the arrows to control the robot, to control the grapper manually. So this one grab is to start the electric suction cup. Release would be released. After the suction cup control interface is configured, we can control the suction cup by using the end tor shortkeys. This is a picture of the end buttons on the robotic arm. You can see we have the different functions here. This is the buttons for the end arms, for the end tors. So what we need to do first is to configure them right in here, and then we can use the buttons to control the robot, to control the end tors and the end of the robotic arm. But now is that end effectors must be adapted. It must be supported by Dobot, and then you can use this button. We will increase more models that we support by this time being. Okay, we will add more models. And those are some API for the effectors, such as this ref epic, which is to initialize it, start it, turn on, turn off the grabber, and so on. So you can also use the APIs in the scripts. Okay, so what do we do usually if we want to use the traditional ways to do the stacking, to do the palletizing? So if we want to move the stack from here to here, so how do we do it? So this is what we do. What we to write a simple palletizing program. You can see it's quite long, and there will be a lot of moves that is repeating. So first we need to do is initialize the grabber. We need to initialize it, and then we write a function that suck up or reset. Suck up would be for the vacuum to working, and reset means to release. So we write these two functions, and we can call them in the main program. So first we go to the waiting position, and this is the point. P3 is the point aboard the first stack suction position. So then all is ready. We go to it, and then we go RP. RP means the offsite of the P2. First we go to P2, and then when we go to offsite, it's about the second stack suction position. So with this, we will go first go to the first points above, and then move to the suction position. We go move and then stack up. This is meaning that we pick up the first we pick up the item, and then we move to up, and then go to the point ball, and then move down. So this 3 is in 1, and this 3 is 1. And then reset means to release the box to the distance, to the destination. Okay, so and then we repeat one by one, a group here and a group here. This is like a movement like this. We go to here, we go to pick up, move to the next position, and then move down. This is a command just like the jump command. And now this is the traditional way of do palletizing. And now we will have this one. This is what we do. We are using this jump commands that we can easily to call in the program So with the jump command, we can save 3 commands to 1. We can change them to 1. So with these 3, we can all change them to 1 jump commands. You can see that we set up some local parameters. We also the definition of suck up and the release, and then go arc. We set the parameter there, and then we use the jumps. We use the jumps for pickups and place, pick and place. So we are using the jump commands to simplify the program before. You can see what we have in here, we can simplify into here. Okay, you can see this is much easier to understand than what we have in here. Shows us 2 different commands. This is jump 1. And here, the RP means the offset, as I mentioned above, and we can put the parameters, the variables in here to definition the pickup pause and place pause, and jump, and use the jump commands to do it. Okay. All right. Here's another thing that there will be a Z limit for the jump commands. You can set up for this one if the second point is higher than the Z limit, the jump commands will just go like here. And if the points is below it, it just go regular like here. Okay. If A and B points are just on the Z limit, it will just go as a straight line, just like this one. All right. And there will be a video here, and I'm going to show you here. Okay, this is what we are using for. This is a short demo for the palletizing. Okay, we start, and you can see this is a video for run this script. And here you can see the 2 indicators, the green one and the yellow one. You can see the green one means the movement of the robot, and the yellow one means the running of the scripts. So you can see that the running of the script is always ahead of the robot's move. So this is why we use sync. You can see that the yellow indicator always stops at sync and wait for the green one to reach it. Then they will go together. Okay, this is a simple demo for palletizing. So this is the basic idea of palletizing, is to move from the stack area to the corresponding place area. If you want to do it, there's a simple way of doing it with the process of palletizing. We are working on the current palletizing process, but it's not ready yet. But I can introduce you a little more in advance. So we have 3 different points that we need to use in the palletizing process. That is point A, which is a safety transition point. Point B, which is a preparing point, and target point is point C. Point B is on the high, on the top of the, usually on the top of point C, but you can also choose to another point. But usually we suggest you to put it right on the target points, just like what we show in the picture. We go to point A, then go to point B, and then placing or picking from point C, and the stacking points as well. We go to we move from point C to point B, and then to move point 1. This is the pallet process in our Dobot Studio Pro, and it goes like this. You can find it on the bar here, and you can choose a different XYZ, different layers, different box, how many boxes in different direction, and you can choose the offset in here. Offset the C, you can choose the different C points, prepare points, first point, the same point in there. This function is not very good to use, but we are working on it, and it should be released soon. So if we want to do the stacking process setting, we need to complete the user's coordinate calibration according to the pallet, and then set the number and offset in here in each direction, and then complete the positioning teaching. So with this way, we get the robot to know the accurate points, and then it will go to pick up and place. So this is API introduction of processing. First one is palletize matrix here. So we have different values. Those parameter is and stick and user frame is just to change the default mode. It's stacking mode without any specific settings. And this user frame is the serial number of the user coordinate system you use. If it's not set, the default value will be 0. And reset and restore the initializing state. Move in means the robot moves from the current position to the first target point according to the configured stacking path. Move out means the robot moves from the current position to the safe transition point according to the configured stacking path. And extend is to check whether the stacking or unstacking is complete. And release means the release palletizing instance. So we have this little demo in here you can use for reference. Okay, we will scrap for the demo, and you can check it for you later. And the next thing we will do is for the complex tracking motion learning. And we're having this training for 1 hour, so I think we will have a rest for 15 minutes, and we will come back at 20. Okay, I don't know what your time is, and my time is 4 p.m. and 4 minutes. Let's come back at after 50 minutes. Okay, let's have a rest, guys. Okay, see you later.